Okay, well, I'm handing back some homework. I got your parser graded. They all look really good. Yeah, the code for the assembler project is coming along quite nicely. There is one question that I had. Like I say, I didn't hand back your code listing, but I did look through all of your code and checked it and made sure that it looked like your finite state machine for your parser. But I had this one question about yours, Kyle. You've got this override.
Mm-hmm.
Now,
I asked you about that in class.
yeah, you did, and I looked into that, and it's necessary whenever you are overriding a method, but I don't understand. If you don't put that in there,
Yeah.
what happens?
It just gives me a little yellow, like, you should put this in here. I think it's just...
It's a warning.
Yeah.
But you're not override. I don't understand why, because...
The methods aren't implemented in the abstract class.
I know,
so
but
you're
they
not really
shouldn't.
overriding anything. I don't get it.
Oh, maybe... okay, maybe I'll check my listing and see if that override warning
If
is
that
in
override is
there.
there.
Okay,
Maybe.
yeah. Because you wouldn't think that, because you're not really overriding it, you're
Right.
implementing
You're
it.
implementing it.
So that's a weird message to come up when you're implementing okay, well,
I don't
anyway.
think it changes the performance.
No, it doesn't. And it's a compiler issue. But did you guys remember, you guys didn't have this @override thing in your, but do you remember, did your code give you warning? Did your IDE give you a little warning?
Not like an error, but like...
Not an error,
Like
but a
a
little
light
yellow. The errors are red, the warnings are yellow. Whenever you, did you have a few little yellow warnings in there that you just ignored?
Oh, actually, yeah, at override annotation.
Ah, there it is. Okay, so now I understand what's going on.
Okay.
So what happens is our compiler is set to flag whenever you are implementing a method that hasn't been implemented in the superclass. But it's strange because in the superclass we said that those are abstract,
Right.
so they can't be implemented there. So you're not really overriding, because in object-oriented programming it's allowable for you for a superclass to have a method that's implemented, and then for the class that inherits from that to actually override an implemented one. And so that's kind of a strange error message. But okay, yeah, so that's fine to keep those in there, to keep those warnings from popping up. Is that not yours?
In front of my test, that's why I didn't catch my
This is.
my addressing modes.
I'm sorry. Say it again.
I had a space in front of my test for my addressing mode, so I didn't catch that.
Oh.
Just one.
Yeah. Yeah, I noticed that. You missed your. Yeah.
It was there, I just didn't catch it.
Yeah.
Mine just
I
doesn't
don't
print out
have
the
the
way I
yellow
want it.
errors. Is it in the translator?
No, it's in the actual classes. Like go to...
Mine
Yeah,
was
it's in the subclass.
Mine was in my non-unary instruction.
Yeah, we found a few little
Yeah.
errors, but anyway, you can see the test suite that I used. I tested it's a pretty extensive suite. I tested every addressing mode, every legal and every illegal addressing mode with every instruction that you're supposed to implement. So it's pretty exhaustive. But anyway, it looks really good. I mean, your error messages are all, catching the errors, and yeah, it's quite good. Okay, now today we have a lot to do. We're going to learn one new concept, and that is how to do call by reference. Now, and furthermore, it's quite interesting because we're going to do call by reference two different ways. We're going to do call by reference when you have the actual parameter is a global variable, and call by reference when the actual parameter is a local variable. It turns out to be kind of tricky. It's going to be interesting to think about this, think about what the compiler has to do in order to implement call by reference. Okay, now, so let's just think about it for a minute before we get into the nitty-gritty details. In call by reference, what you have to put on the runtime stack is a reference to the actual parameter. Are you with me? Because in the function that's using that parameter, if that function changes the value of that parameter, that formal parameter, really what is it changing? It's really changing what? the actual parameter. Are you with me? Is everybody clear on that? Okay, so how do you pass a reference to a, to a variable? What must we give to the function?
Is it like a pointer? To the...
Yeah, and what are pointers,
Like the address
basically?
of words.
They are addresses. Yes, they are addresses. Are you with me? Now, so let's think about that. The function that is going to have on the runtime stack not the value of the variable, a copy of the value of the variable, which is what it would have if it were called by value, it's going to have what? The address. So think about that for a minute. If we're here on the runtime stack somewhere, okay, and here's our stack pointer, and if right here, say that this value is one of the parameters, okay, that got pushed onto the runtime stack with call by reference, the stack pointer is pointing here, then this is an address. If we want to like store 5 to that variable, we don't put the 5 here. What do? We use this 5 as the what? As the address of where to put the 5. If we're doing that variable gets 5. Are you with me? So what do we need? We need to have an addressing mode that does what? That takes whatever the stack pointer is, are you with me? Adds the offset, the stack relative of this, but then instead of having this be where the operand is, this is the what? The address of the operand. So what we need is deferred. We need to do the same thing as stack relative addressing, but it's not just stack relative addressing, it's stack relative addressing deferred. So here is how the stack relative deferred addressing mode works. The assembly language 5 letter is SF, which stands for stack relative deferred. And you can see, it's easy to see what it does here. It takes the stack pointer plus the operand specifier, adds those together, and then mem sub that is this, and then memory of that is where it is. So do you see then that by access a variable on the runtime stack when it's called by reference, the only thing we need to do is use stack relative deferred addressing. And that's built in, that deferred is built into the addressing mode in PEP 8. It's one of the 8 PEP 8 addressing modes. And you see why we have it. The reason we have it is when we have addresses on the runtime stack. Okay, now, so that's the main idea. And that concept works regardless of whether the actual parameter is a local or a global. I mean, the only difference between a local and a global is how do you get the address onto that runtime stack in the first place. So the first thing that we're going to do is global variables. Now, tell me, in the C++ memory model, where are global variables stored?
Fixed location.
At a fixed location memory. And how are they allocated?
Using dot block.
Using dot block. Using dot block. So here we would have, over here in a fixed location in memory, we would have our global variable, and it would be allocated with dot block. And tell me, when we allocate that with dot block, we put a symbol in front of it, right? Mm-hmm. Like if this symbol is alpha, say. And tell me, sports fans, what is a symbol?
The address.
A symbol is the address of where that is stored. Mm-hmm. Yeah? Are you with me? So the question then is, how do you push that address onto the runtime stack whenever we are pushing the parameters? I'll tell you. Can you think through that in general here before we do an example?
Would you store accumulator, like load accumulator alpha, store accumulator alpha, stack relative?
Now, that is so really good. What you would do is you would do load accumulator alpha, but big question, load accumulator, you'd say load accumulator alpha, but my question is, what addressing mode?
Immediate.
Isn't it direct? Isn't only the dot equates immediate?
Well, but if alpha is the address, that's what you want.
That's exactly right.
Oh, because you're storing that.
You want, what we need is that was really good. So it's load accumulator alpha immediate. Now, when you say load accumulator alpha immediate, what are you putting into the accumulator? The address and memory of where it is. And then you would store accumulator, and then how would you push it onto the runtime stack? Well, it depends, you know. It would be store accumulator, and then it would be something like, I don't know, -6, wherever it is, whatever, you know, wherever it is. And then this would be what?
SF. Or no, you just put it on the stack.
Now we're just putting it on the stack. This would be what? This would be S. Are you with me? So you'd load accumulator alpha immediate, store accumulator negative, you know, whatever, this is whatever it is, and then stack relative. But then when you are up here and you are accessing it in the function,
Oh, that's when you call it.
that's when you use the SF. So does everybody understand? That was really good that you could get that conceptually. See, there's nothing special we need to do here. We just use immediate addressing. We already have it. It works this way. All right, so here's the recipe. And this recipe has to be built into the compiler. The compiler has to know how to do this. This is in the code of the compiler. So here we have the recipe, call by reference with global variables. To push the actual parameter, you use load accumulator with immediate addressing. And then to access the formal parameter, you use stack relative deferred addressing, SF. Okay, so that's what you have to remember. And here is how we're going to do it. Okay, so here's our example. Do you remember this example? Actually, let's go to the main program first. What this main program does says enter an integer, CNA. C out, enter an integer, CNB. And then now we're calling order AB. Are you with me? Now, what are A and B, actual or formal?
Actual.
Those are the actual, right? So, how does order work? Well, let's come up back here and see what void order. Now, we say void order int ampersand x int ampersand y. Ampersand means?
Just
Means call by? Means call by reference. So the compiler has seen that and says, oh, that's call by reference. I need to push the address. Are you with me? So it pushes the address on up there, and there we have x and y. So now what order does is if x is greater than y, swap xy. Wait a minute, it's calling swap xy. But now we go up to swap. Now what is swap? What are the parameters for swap? R and S. So R corresponds to X, S corresponds to Y. But those are both called by what?
Call by reference.
Called by reference. So here when we say int temp, which is our local variable, and we do temp gets R, and then R gets S, and then S gets temp. Well, when we're making those assignments to R and to S,
Making it to that.
yeah, R refers to X, but X refers to A. So we're really doing it to A. We actually looked at this when we reviewed C++ earlier in the semester. I don't know if you remember this example. Okay? Are we good? All right, so now what let's do is let's see if we can translate this program. Okay, so I think what we'll do is, let's come over here and let's draw a picture of the runtime stack with, you know, the first call and then the second call and then the third call. I mean the first call and then the second call, rather. So what we're going to have is, actually over here we'll have, what was this local variable called?
A.
Oh, there was our A and a B? Yeah, right, okay, so.
Actually, they're
They're global.
Yeah, they're globals, right. So this will be the global space. So here's A and here's B. And then on the runtime stack, what will we have here? So, and in the beginning, let's move this over here a little bit. So here's SP. And so in the beginning, this will be here. And then when we call, so what does that do? That calls order, okay, which, oops. And then does order have any, order is void, right?
Mm-hmm.
So there's no ret val. So what's,
X.
is that what it will look like? Oh, yes, it will. X. So it'll be X first, is that right?
Mm-hmm.
And then Y, and then what? Return address. Okay, and now, any locals?
Temp.
And swap there's
Is this swap or order?
Order.
This is order, right? It's calling order. So this one's order. So there are none. So is this the stack frame?
Yeah.
Okay, so that's that stack frame. And then what?
And then we call swap.
And then we call swap. Now how are we going to call swap? First of all, it's void, right? So then what?
We have R and S.
So this is R. This is S.
And then we have the return address.
And we'll have return address.
And then temp.
And then what?
Temp.
Temp.
New stack frame.
And that's the new stack frame. Is everybody clear? So at one point in time, SP will be here. At another point in time, SP will be here when we are in order, right? And at another time, SP will be here. Is everybody clear? Okay, so here's the, so we can remember this is when we're in order, and here's when we're in swap. Okay, so now let's just start from the top, and this time let's do it in the order that we get it here instead of doing main first. But it's kind of tricky though, because you have to think what's going to be where, I mean, anyway. So the first one is what? Branch to main.
Yeah, that would.
It's kind of, you have to kind of think ahead, you know what I mean? Instead of writing it in the order that it's being executed, you have to, of course, the compiler has to write it in the order that it gets to it.
Yeah.
The compiler translates it. So we're more like a compiler now. All right, so now, what do we have in swap?
We have R.
We have R.
Well, first, don't we need to add the
Oh, wait,
global
the
variables A and
globals.
B?
Yeah. Do we want to adopt?
Oh, yes, yeah, we do. Yeah, we do. We do need the globals. Good call. So what do we have here?
A.
A,
Dot block 2.
dot block 2,
Which is
and trace tags. Let's hurry along. And then B,
dot block 2.
I assume, you've noticed that I take off points when your trace tags aren't right, so I assume that you can work those out yourself. Dot block 2, okay.
Swap.
Yeah, but now, what does swap, but now swap is going to refer to what variables?
RS.
It's going to refer to R and S and temp.
Yeah.
Are you with me? So here we need R, and we need S,
Okay.
and we need temp.
Not one right one.
And so now so now we have to come over here, right? Because, wait. Oh, yes, we will be up here. Yeah, not in the order that we're executing. Yeah, so we will be up here. So what will our offsets be?
R equate will
2,
be
4,
6.
6,
S will be 4.
4.
And temp will be 0.
6, 4, and 0.
Dot equate.
Dot equate. That equates 6,
4.
4. Yeah? And now, you guys, the very first thing we have to do in swap, so this is swap, is to do what?
Sub SP.
And how much? Yeah, now here, let's come over here. When we will be here when we get to swap. So 2. Now, is everybody clear on that?
Right.
You see how to do those now?
Yeah.
So sub SP, I do this a while. Okay, so
Immediate.
2. And that's immediate. And then trace tags. Okay, and now what?
Loading temp.
Yeah, now load accumulator, temp.
Wait, what?
No, not temp.
No.
It's temp gets R. We want to load accumulator R, but now here's the scoop group.
OSF?
Aren't we still
No,
loading
immediate, we're
it?
doing stack relative.
No. We are in here. We are, let's come over here. Here we are. We are here, right?
Oh, it's gonna be pushed as an address, so we wanna do.
We are going to be here, and we want to load accumulator R, right? But we don't want,
But it's not,
But
it's
isn't
not
R
a
an
pointer, so shouldn't it, because it was like temp star, then you would swap the addresses, but since it's not a star.
it's, no. Yeah, oh, that's a really good point. These are not pointers.
So
When we say, when we say temp gets R, what we want is we want temp to get the value.
Okay, not the address.
Yes.
So.
Because temp is what kind of a variable? It's an int.
Right.
So where is the int?
It's in the,
R.
This is the address of where the int is.
which points, so we need the SF.
Yeah, so this R, right. So we need to do load accumulator R, addressing mode, SF. Now that was really important to work through in your mind. Make sense? And then what?
Store the accumulator.
And now store accumulator, but now where are we storing it to?
Temp.
To temp. But what kind of a variable is temp?
Well, it's a
Local variable.
so
It's a local.
Stack relative.
So S. Yeah. Ooh, this is good. And then what?
load accumulator,
Load accumulator,
S,
S,
SF.
SF.
Wait,
Oh, yeah, wait.
no.
guess
Well,
No.
is
It's
it?
better to do it that way. Because don't we just need the address?
No, wait.
No.
Yeah. See, the compiler is dereferencing this. That's the thing about call by reference. It's dereferencing it automatically. When you say, these are not pointers. This is the difference between a pointer and a reference, is what the compiler does at this point in time. Because when you say R gets S, what really are you saying? What does R correspond to?
The formal.
No. I mean, when it got called, R corresponded with X, but X corresponded with what? A. So when you say R gets S, what are you saying?
Don't we want R to point?
You're saying A gets B. And you want the value. Well, you want the value of B to go to here.
That's who we use.
So you're
So use SF.
so use SF. Okay. So load accumulator S SF. Then what?
Store accumulator.
Then store accumulator
R.
Stack relative.
R SF.
Oh, yeah.
Are we good? Okay. And now what? Yeah, it's really important to kind of visualize how that works.
Now we load the accumulator.
And now we load the accumulator what?
Temp stack relative.
Temp stack relative.
Store the accumulator.
Store accumulator
S. SF.
S. Oh geez, S and S. S. I should choose different letters. S and what?
SF.
SF. Right.
Now we return 2.
And now we ret 2. Because 2 bytes of temp that we need to. Are we good? So now how about our environment for order? Now what variables is order referring to?
X and Y.
X and Y. So here we have X. So now how about X? Now let's come over here. So we have to look over here. SP will be here, right? So X will be at what? 4. Y will be at 2. So X
Dot equate to.
dot equate 4. Y dot equate 2. And now we are doing
If state.
order, right?
Order.
And do we have any locals? Nope. Nope. Oh, the only thing we do is swap. Okay, now, haha. So the stack pointer is here, right? So we have to call, now we have to call this function. So we got to put something in R and we got to put something in S. So R is at -2 and S is at -4
Right.
compared to where the stack is now. Is everybody good on that? But now, you guys, what does the compiler have to realize? The compiler has to realize that it has been given a what?
Address.
An address.
Don't we want to push the address?
And so that same address that is here is the address that has to go here.
So you just load accumulator
Just
immediate.
use stack deferred.
Oh,
Or you store it.
whoa, now I've immediate stack deferred stack. I mean, or direct. Those are the ones we know.
You load accumulator immediate.
You would load accumulator. Whoa. If you did load accumulator, okay, let's think about that. If you did load accumulator immediate, you'd be loading it with
But they're not,
4.
because they're not local.
So stack.
It's stack.
If you did load immediate, see
I'm
if
thinking of how a
here we know it's going to be load accumulator. We know it's going to be load accumulator X something, right?
Wait, don't we have to
it's gonna be
compare them
it's gonna be
first?
S.
Huh?
We have to
We need to
compare
compare
them
them
first.
first.
Oh, we need to compare. Oh, that's right. Oh man, I was doing the pushing and
Well, you
and
still-
we were needing to do the compare.
You still have to load it.
But it's going to, yeah, but now it's going to make a difference. Yeah, I wasn't. I
Load
was-
accumulator X and then
Yeah. Okay, so load accumulator X, but now to compare it,
Because don't you want the value?
we want to compare the values. So SF.
Yeah, you can.
And then compare accumulator,
Y.
Y, what? SF. And now we branch, now the test is
Greater than.
greater than, so we branch if what?
Less than or equal to.
BRLE, and now what? To end it, to end if,
Yeah.
see? And now what do we do? And now here's the code where we do the,
Now we load the accumulator.
so now we load the accumulator, now we have to push, yeah. I was getting ahead of myself, sorry. So load accumulator X, but now,
Just S. Because don't we just want to push the address?
yeah, now that is really super thinking. Is everybody with me on this? This is just S, not SF. Why? Because we're getting that address into the accumulator. And then store accumulator what?
-2.
Yeah, and we showed there, it's -2, right?
That's SF, right?
Not
Mm. Here, oh,
Because we're storing that same value. That's fine. Yeah.
it's just relative to here. We're putting it there. So it's S. So load accumulator X, S, store accumulator -2, S. See, as long as you think, you don't have to memorize this stuff, as long as you think in your mind exactly what's going on. And that's what's really good about understanding how the compiler implements call by reference. Okay, so then what?
then load accumulator Y.
And then load accumulator Y,
Stack relative.
stack relative,
Store accumulator -4.
store accumulator -4, stack relative, yeah. And then what?
And then sub SP.
Sub SP, how much?
4. Because doesn't the call
The call-
4, and then the call, 4,
That's right.
and then the call does the 2 more, right?
Right.
And what are we calling?
Swap.
Swap. And then when we get back, we'll have to do what?
Add SP for immediate.
add SP. Oh, we forgot the immediate. For immediate, right? And then what?
Ret 0? Yes.
Yeah.
We need the end if before it though.
Oh, yeah. Oh, we need the end if. Oh, well, this is the end if.
Yeah.
Right, so just put that.
Okay. Is everybody good? Now, here's the thing, you guys. This, it doesn't matter whether we do, when we do, if we do an example with call by, if we were to do this with those variables being on the stack, and we did call by reference with local variables instead of globals, this code would not change. It can't change. Is everybody good? Okay, so now what? So now what do we? How do we do our main? So here's our main.
Okay, this is where I was thinking immediate, because when you're going from a global variable A and B,
Yeah,
then you'd use immediate.
yeah. To get it on there. Okay, right. So let's do it. So let's what stro?
Yeah, show message one. Or show message one.
Message one direct. Okay, and then what?
Desi.
And then deci. A. This time it's what?
Direct.
Direct, because that's a global variable. Are you with me? Now, are we ready to push? Oh no, we got to do the other one. So stro,
Message one.
same message. Oh, that's nice. Okay, and then deci what?
B direct.
B direct. And now are we ready to push?
Yes.
Okay, so now
Reload accumulator.
we load accumulator. What?
A.
A
Immediate.
immediate.
Because you want the address.
Because you want the address. Yeah. And now store accumulator. Now we are here, right? And we're going to store it here. Is that right?
Yeah, so negative two.
So negative-
Stack relative.
-2 stack relative.
Wait.
Are we
Yeah,
good?
yeah, because we access it with stack deferred.
Right. And then
And then load accumulator B.
load accumulator B,
Immediate.
immediate,
Store accumulator negative.
store accumulator -4,
Stack right.
stack relative.
And then, no, sub SP 4.
Immediate.
Call order.
And then we sub SP here, so after the call we
Add SP.
add SP for immediate. I think we're done. Oh, we have to do some more
It's really just
blah, 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 blah.
Stro message.
Stro message, blah, blah. Okay, are we good? All right, let's see if we did it right. Okay, there we have it. Check us out. Do we have AB, dot block 2, dot block 2? There's the nice trace tags. Do we do RS and
Yep,
temp? Okay.
perfect.
And now what about, now the key thing is these, did we do these okay? Temp S, RSF isn't, yeah?
Yep.
Good. Okay, next one. Okay, so did we do these right? Boom, boom. -2, right? Yeah? I don't think there's any optimizations here. I think this is just straight translation. Are we good? Okay, and here's this one. Let's see if that immediate worked. Is that here? Load accumulator
Yep.
immediate? -2, B immediate, -4, sub SP, boom. All right, good deal. And you know, I could give you a demo. It's actually kind of cool. We don't have time, but it's really neat to see. Now, the one thing my app doesn't do yet, which would be really cool if it did, would be to actually have a little arrow.
Stack pointer.
You know, to have those the arrows go down. It's an interesting computation problem for a debugger to actually be able to do that, and it's doable, I'm sure. It's something I had in the back of my mind that would be really nice to do. And so here you see in part A of the figure is that graphical representation of what they point to, but here it's the actual. You know, actually, the one in part A is a reproduction of the stack frame that we did in chapter 2. But here you can see the actual values, the actual hex values of the return addresses and the references. Okay. Are we good? Now let's think about the next kind of the next situation where we want to use call by reference, and that's when the actual parameter is a local variable. Now think about this one really hard. Think about this.
If it's a local variable.
If it's a local variable, actually we're going to use a completely different example. So
Well, it's trickier because you can't just give it an address because the address for the local variable is stat relative.
well, yeah, that is way. Yeah, now and this is the one area, yeah, that's really interesting. So, yeah, think of it like this. Suppose we have suppose here's our stack frame. All right, for the main program, okay? So suppose this is our stack frame for the main program. And suppose that we want to do call by reference of this local variable right here, okay? So the problem is, how in the world, what is the address of this? I mean, if it were global, we know that the symbol is the address of where it's stored, right? But here, what's the symbol? It's not the address, it's not the absolute address of where it's stored, it's the what? What would the symbol of this one be for this example? It would be 2. Its value would be 2. Well, we don't want to push 2 onto the run because 2 is, that's not where it's stored. It's stored way down there in FFD or someplace, So what do we need? In order to do this, what do we need? This is really tricky. No, actually,
Because don't we need the address of that spot on the stack?
yeah, we need the actual address of this. And where is it? It's way down there in some...
Is that the program counter?
No. Actually, what is it? Where is that?
Stack pointer plus
The
2.
stack pointer, yeah.
Yeah, so what we need to have access to is the stack pointer. The value that's in the stack pointer. Are you with me? Now, where is the stack pointer in the...
In the register.
It's a register in the CPU. It's a register in the CPU. We need to have access, and what do we have to do to that stack pointer value?
Add
We need to-
specifier to it?
Yeah, we need to add 2. Well, right, yes, which in this case would be 2. We need to get the value of the stack pointer and add 2 to it, and that's what we need to push. So what do we need? We need an instruction that does what? That takes the value of the current value of the stack pointer and puts it where?
Into that
Into the,
location.
no, into what?
Somewhere where we can get it.
Well, somewhere where we can add 2 to it and then push it. So where does it? Into the accumulator. Exactly. We need an instruction that will take the value of the stack pointer and put it in the accumulator. Are you with me? So look,
I'll move it.
guess what the instruction that is? The move stack pointer to accumulator instruction. And it's for just this purpose.
Seems a bit unnecessary.
No, it's absolutely necessary. In fact, this feature was suggested to me by a reviewer of the book in a way long time ago. He said, in order, because, in earlier versions, like in PEP 7 and PEP 6, I forget if PEP 7, I forget where, when this was introduced. I forget if it was PEP 7 or PEP 6, or I don't think it was PEP 5. I think it was, but anyway, somewhere on a previous iteration of this, all the architecture of the chip has evolved, and so a reviewer suggested this. He said, if you had access to the stack pointer, then you could do call by, then you have to have that in order to do call by reference with local variables. So look at here. There's the instruction specifier. It's move SPA, and the accumulator gets the stack pointer. There it is. See the RTL of it? Isn't that simple? So is this a unary or non-unary instruction? It's unary. Okay, it's one of the very first ones. It's the, you know,
Like the second.
third maybe. 0, 1, 2, yeah.
This is
It's like the third one.
Return from trap. And then
Stop, return from trap, and then this one. Okay? So now tell me, how would we get this onto the runtime stack? How would we get this on, what sequence would we use? So like if this was, if alpha, so in this case what we would have is we would have like, it would be alpha, and then that would be dot equate 2. I mean, if this were where alpha was. Are you with me? And then how would you push that? So then what would, so this is what, and then how would you push it? You'd say what?
Moves.
You'd say MOV SPA, move SPA. Okay, so move, wait.
Spot.
SP. Yeah, confusing. I was thinking move S to PA, but it's move SP to A. But anyway, it's move stack pointer to accumulator, and then what?
Add SP.
And then add SP.
No, add A.
No, add A. You're right. You're right. Add A and add A what?
2.
No, no, no.
Alpha.
Alpha, because that's what we're doing. Are you with me?
Wait.
Oh,
Add A alpha. Now, addressing mode.
direct?
Immediate.
S.
Yeah, direct immediate S. You want to chime in, SF? You want to chime in? You guys want to chime in?
I think it's, oh no, because it's stack relative.
Yeah.
He's right, because it's a local. No, because then you're going to add it to the stack.
Like pointer.
Oh, this is really good. This is really good.
What is alpha?
Alpha is 2. And the reason it's 2 is because it's 2 down from the stack pointer.
Oh.
Are you with me? So this is where...
So immediate.
Immediate.
Okay.
Which is what you said. Huh?
That was funny.
Ashley's right. She wins.
Yeah, she wins. Okay, so yeah, is everybody good? So you got, if you get the concept, then everything is natural.
Ask what it is.
Okay, and now what? But now what?
Now we want to, well, we're going to store it wherever we want to push it. Right?
Yeah, so we store accumulator into like negative wherever, wherever it's going to be up here. Are you with me? Like -4, I'm just making up. This one could be anything depending on, and the addressing mode, immediate, right? Okay, so here is the recipe. That all is summarized by this call by reference with local variables. To push the actual parameter, you use the unary, move stack pointer to accumulator, move SPA, followed by add accumulator with immediate address. Oh, with immediate addressing. So we just figured out. Huh? And then to access the formal parameter, you stack relative deferred just like before. All right. So now, this next example that we're going to do, I think what we'll do is, oh, where's the code? Hey. Oh, yeah, that's the C++ program. It's all in one thing. Okay, so there's rectangle, and P is the perimeter, W and H are the width and the height of the rectangle. Are you with me? Is everybody clear? So I think what we'll do is, I don't think we'll have time to do the code for the rectangle, but that's pretty simple because we already know how to do call by reference in the function. So let's just do the call, right? So int main, int prim width height. So now let's draw. Let's draw the runtime stack. So what will we have? Prim width and height. So here, param, width, height, okay? And that's going to be the main program, right? The stack frame for the main program. And then, well, so let's go ahead and define param, width, and height. So param width height. Okay, so this will be dot equate what?
6.
Because at this point, the SP will be here, right?
So 0 to 4.
4.
No, wait. Param will be what? SP will be here. SP will be here after we sub SP.
It is
Right. So prim will be what?
4.
4?
2.
0.
Yeah.
Anyway, I said that everyone's.
4. I didn't hear. I heard something else. 4, 2. But my hearing's not very good. So now, and so now what's the first thing in? Now what's the first thing in main? What's the first thing in main? Gesundheit.
We have to
It's
sub SP.
Sub SP 6 immediate because to get to allocate, okay. And now let inner width, inner height, blah blah blah. So let's just do dot dot dot. And now how do we call rectangle, the RECT function?
So now we're gonna.
So now param is called by reference.
So to mob spot.
So we do MOV, what do you call it? Mob spa? So mob spa, now what do we mob spa? What do we mob spa?
It reminds me of mob spot. I don't. We want to do.
Nothing.
That's unary.
It's unary.
Oh, that's unary. Trick question. I was just trying to figure you out. Okay,
Add accumulator.
add accumulator. Now, add accumulator, param,
Immediate.
immediate.
You got that one.
And then what? And now what are we doing? Because we're building the stack, and what are the variables? P, W, and H?
So store accumulator.
So this is going to be P, W,
Really better down to that.
and H. And so store accumulator what?
-2.
-2,
Stack relative.
stack relative. Wait, yes. Okay. All right, and then what?
And then can you just add accumulator?
Now we load,
No. Now we got to do the W and the H. So let's review that. How do we do that?
load the accumulator
Load accumulator what?
with
Width, addressing,
stack up.
Wait, don't we have to do it the same way we did param?
But they're not. They're
param is called by reference, width,
those ones
width and
are.
height are called by value.
So
Okay.
just S with S.
Width, comma, S, yes. And then store accumulator what?
-4S.
-4S. And then load accumulator what?
Height.
Height,
Store accumulator.
S.
-6S.
store accumulator, say it again,
-6S.
-6S.
Now we
Sub SP.
sub SP.
Now we sub SP, how much?
6.
6, I think, right?
Yeah.
Yeah.
6, immediate,
Call.
call,
Rect.
rect, and then
Add SP.
add SP,
6 immediate.
6, immediate, dot, dot, dot. Are you ready? There's our super addressing modes. First of all, did we do param, width, and height correctly?
Yes.
Okay. And then we sub SP 6i. Now how about this point right here?
Looks good.
Move spot.
Moves up, add a param immediate,
Yep.
-2s, width, store, -4. All this is correct? All right.
Yay.
Good job.
Then you can compare it to
Okay, yeah, there's a question about the homework.
For modulus, do you do a arithmetic shift right or just rotate?
No, was it mod 2?
Mm-hmm.
Okay, so mod 2,
it says
What I was
if
trying-
mod 2 equals 1.
if mod 2
If
equals,
mod 2.
okay, now, yeah, the question was, if mod 2, here, let's come over here. If
Something mod 2.
That's fine.
Is it M?
Yeah.
Yeah, sure.
Oh, is it M?
It might be.
Is it M mod 2, or, it's yeah, if M% 2
Equals
equals 1, like this.
Yeah.
Okay, there's actually a couple slick ways to do this.
I know, I
Greg
was,
has a really slick way to do
How was your
I
way?
did rotate right and then branch on C.
You can do,
it too, but
you can do arithmetic shift right and branch on carry.
Yeah. Go ahead.
I anded with one immediate, and then compared cumulative.
Yeah, and you can and this with one immediate, because that's the mask.
That's cool.
Either way, I think actually both ways take 2 instructions.
Yeah.
But that was a good,
So the way rotate right, and then what?
And then
Branch on carry.
Branch on carry.
Oh.
yeah, actually, or arithmetic shift right.
Either way would work.
Either way would work.
But do you still have to do compare? Like, cause
No.
Well, you are comparing when you do branch on carry. That is the compare.
okay.
You don't have to use CPA.
Right. It just wasn't working. It wasn't.
No, you can't use, no, you can't use CPA. Yeah.
It was-
Because that will change the, that will,
Change the carry bit.
yeah.
It wasn't. I guess it wasn't working the way I wanted it to. I might try the and.
Yes.
It wasn't branching when it should have.
Yeah, but that was a nice solution. You mask out all the ones except the rightmost bit. Yeah. mhm.
And you said that one,
I just divided by 2.
you compare that one with 1, so if it's 0, it'll be 0, if it's 1,
Mm-hmm.
it'll be 1.
You know, actually what I could have done, I mean, yeah.
Can you not just do a shift right? and-
See, what I could have done is I could have written the C++ code with that mask and done a bitwise and.
Yeah.
I could, because there is a bitwise and operator in C++. And that way it would have been a direct.
But it's okay to figure it out.
It was. I think it's better to figure it out.
I wrote a nice list.
Actually, yeah. All right, good deal. See you next time.